Click the bell icon to get latest videos from Ekeeda.
Hi guys, this is the video for numerical example number 2 on DC analysis of BJT. Let us start this particular numerical, which is based on voltage divider bias. This is the circuit which is given at the input side CC1, at the output side CC2, जो कुछ काम का नहीं है. Right? For DC analysis, we have to open it obviously. So this input voltage VI, AC input voltage VI and the output voltage VO has nothing to do with this circuit, right? As far as DC analysis is concerned. Okay, so we will start with the given and we will start with the requirement. So the given is value of beta, which is nothing but 100. Only that much is given, the rest part is given over here only, right? And of course VCC is equal to 18 volts. Okay, then we'll have to find operating point and we'll have to decide whether circuit will work as an amplifier, right? That was the question. So this numerical is divided into two parts. One is usual operating point, that is Q point, and second one is whether circuit will work as an amplifier or not. For that we have to decide about the region of operation. Okay, we will go step by step. Step number 1, that is so we are opening CC1 and CC2. There is no question about bypassing. So what we'll have to do? What we'll have to do is drawing another circuitry. So in step number 2, we'll have to go for the Q point parameter. We will apply first KVL. But there is a problem. See, this circuit is voltage divider bias. So first of all, we'll have to simplify this circuit. So this is the required step number 2 actually. Okay, we will go for finding VTH. VTH, as we have learned, R2 upon R1 plus R2 multiplied by VCC. So we will put the value of R2 and R1 and VCC. We will be getting the value of VTH. Your answer is, so this is the value of VTH, and now we will proceed further for the value of RTH. It's a simple R1 parallel R2, 47K parallel 10K, and it coming out to be 8.25 kilo. So far we have got VTH and RTH, so we can easily form the Thevenin's equivalent circuit with voltage divider bias. And we will name this as for this circuit. We will go for the analysis and then we will implement the input KVL over here and output KVL over here. We will apply input KVL first. which was the first step number 2, which was the first sentence in step number 2. We'll apply VTH minus RTH into IB minus VBE minus IE into RE is equal to 0. From here we will be getting the value of IBQ is equal to VTH minus VBE divided by RTH plus 1 plus beta times RE. Just put all the values. VTH is 3 point something, VBE is 0.7, RTH that we have got 8 point something, 1 plus beta is nothing but 100, so 101 multiplied by RE is equal to 10k, and with all these values you will get answer of IBQ as 2.414 micro. So we'll find out the value of ICQ very easily, that is nothing but beta into IBQ. Beta is nothing but 100, so your value will become 0.24 milliampere. After finding the value of ICQ, we will proceed further to apply output KVL. VCC minus So after applying output KVL, we will be getting VCC minus ICRC minus VCEQ minus IERE is equal to 0. And from that we will get the value of VCEQ as VCC minus ICRC minus IERE, right? Now we'll have to put the values and get the answer. Very simple. The value of VCEQ will come out to be 15 volts. So now here we have got the value of ICQ and VCEQ, nothing but the parameters of Q point. These are the two parameters of Q point. Now another question they have asked us, whether with this Q point my circuit will work as an amplifier or not, right? So for that we have to draw the output characteristics and we'll have to mount this particular point on your output characteristics, and then we will get to know that whether your circuit is working as an amplifier or not. This is nothing but your Q point, right? And where the value of ICQ is very less, that is 0.24 milliampere, and the value of VCEQ is very high, near to VCC, that is 15 volts. Your VCC value is 18 volts, right? And if we try to have the swing, right, we will not get the proper complete swing of your input, right? That's why this circuit will not properly behave as an amplifier. Another reason, specific reason, is your Q point is in cut-off region, because this is your cut-off region. So there are two reasons on the basis of which we can conclude that this circuit will not work as an amplifier. Because a part, Q point is in saturation. This Q point is in cut-off region where current is very less and your voltage is near to VCC. B point is and due to the fact of A, I will not get the proper swing. And that's why the circuit will not work as an amplifier. That is the answer of second question, right? Here we'll draw the simple amplifier, and where we'll be getting the clipping, and it should not be the part for amplification. Clipping should not happen in your amplification process. So that's why this circuit will not work as an amplifier. So far we have discussed about the conceptual as well as mathematical thing of the numerical number 2, which is nothing but the voltage divider bias with DC analysis of BJT. Thank you so much for watching this particular video. We will learn more and more complex numericals based on DC analysis of BJT. So for that, we'll have to stay tuned and learn more and more ADC along with me, along with Ekeeda videos. Subscribe the channel of Ekeeda. Thank you.